All right, welcome back. So we are on page 2 of the Chapter 6 review for logs. And in this section, we're going to focus on expanding and condensing. So when we're done with 19 and 20, we want them to look like 21 and 22. And when we're done with 21 and 22, we want them to look like 19 and 20. So the first thing I typically like to do is when I expand is just ignore the log. And I see this as 4 times the cubed root of x. And then what I'm going to do is take that times sign and change it into an addition sign. And then the other thing is we don't typically have cubed roots. Instead we have exponents. So I'm going to change the cubed root into the 1/3 power. And now what I'm going to do is take each term, the things separated by addition or subtraction signs, and put this log 7 back in front of each one of them. So log 7 will go in front of the 4 with my plus sign, and log 7 will go in front of x to the 1/3, but the 1/3 won't stay here. It's going to move right in front and become a multiplication problem. So when we're done, that's how 19 looks. So let's take a look at 20. We're going to expand again. I'm going to ignore that ln, and I see x squared divided by e become x squared minus e. And now this term will get the ln, and this term will get the ln that I was ignoring. So ln x, but instead of the squared sitting there, it's going to move to the front. And then an ln will go in front of this. Now, this is a great answer. If you happen to notice on your test that you can do a little bit more with this one, that would be great. So what can you do with that one? Well, this is just asking me e to the what power gets me right back to e. This whole thing can actually turn into 1 because e to the first power gets you right back to e. Can't do anything with the first one. So this is a good answer, but what's in black is the preferred answer. But either way, both are great. So now with 21 and 22, what we're going to do is go from 3 logs down to 1 log. So I know in the end I'm going to have a log 5 in my answer, and over here I'm just going to have a log with that understood base of 10. And what I'll do is ignore the log 5s and bring this stuff multiplied to the back. Okay, make it its exponent. And here was a plus, here was a minus, and that plus will turn into times, and that minus will turn into division. And it'll be, the first one goes in the top in a numerator spot, x times y squared. And then anything that's divided is always in the denominator. So z to the 1/2. If you'd rather, you can put that z in a square root. That's okay too. Let's take a look at 32. So on 32, again, I'm going to go from 3 logs down to 1. There's the 1 log. I'm going to move that 4 back as an exponent. And I'm going to ignore those logs as well. And I'm going to move the 2 back as an exponent. And now anything that's subtraction becomes division. And this will start on top. So x to the 4th. And y is being divided, so it goes in the denominator. And z squared is being divided, so it's also going to go in the denominator. And for both of those, if you'd like to put the whole argument in parentheses, you can. In this case, since it's all multiplication division, you don't have to. But here are my final 2 answers. Let's get into solving. So for solving, remember, most likely we're going to work backwards in the order of operations. I think that's probably the best way to do it. And some problems will always be a little unique, but let's go ahead and get started. So here, what I want to do is get this log isolated. Here's that checklist. So what I'm going to do is first is add the 3 over, which gives me 5. There is no multiplication division to undo, so now what I'm going to do to undo my log is I'll make an exponent. So I need a base of 4 and a base of 4. And then my exponent problem needs an exponent, so this will become the exponent, and this will become the exponent. And then we can undo that log now because these 4's cancel out, and I'm just left with x. And then here, 4 to the 5th power, whatever 4 to the 5th power is my final answer. So 1,000 24. So on the next one, I'm starting out with an exponent problem. So what I will want to do is realize to fix that, I'll make a log out of it. So here what I'm going to do is add the 4 over. Now once I add the 4 over, some of you might see that you could actually find a common base between 8 and 4, and that would be 2. So one option is to turn 8 into a base of 2 to the third power, bring in the original exponent in parentheses, and make 4 into a base of 2 by doing 2 to the second power. And then once those bases are the same, you can make it 3 times x equals 2, and then when I divide, I get 2/3. If you don't see that, then again, we can work backwards. There is no addition subtraction move because this is 8 to the x. There's no multiplication to move because it's 8 to the x. So to undo the exponent, I'll make a log. So I log the left and I log the right. My exponent problem needs a base of 8 and a base of 8 because that's the base of the exponent. And then both logs need the argument. So this becomes the argument and this becomes the argument. And then these base 8s cancel out, so you're just left with x. And then here you can press your math button. You can scroll up, get your 8, put your 4 in, and get the same answer. So 0.6666 is just 2/3 as a decimal, but I will round it. So either way you feel like. So on 31, what I notice is that I actually have a log on both sides, but I can't quite cancel them out yet because this isn't a log yet. This is, there's a 1/3 in front. So what I'm going to do is this, which I think sometimes we forget about it in a problem like this, is I'm going to move this 1/3 back as an exponent. And I'm hoping you remember that a 1/3 power is like a cubed root. So this is the same as me taking the cubed root of 8, which is actually 2. And then I don't need to do anything to the other side. So as far as a problem goes, this is very similar to like taking this route. And now that it's just one log with the same base and another log with the same base on other sides of the equal sign, we can drop those. This becomes the math problem, and now to solve for x, I just add that 9 over, and you get 11. On this one, this is an exponent problem. There's a lot. Well, there's not a lot to move, but yeah. So what I'll want to do here is to start to get this base and exponent alone. This is -1/4 times 2 to the -2x power. So I never sent any addition subtraction, but this -1/4 was multiplying all of this, so I'm going to move it by multiplying by the reciprocal. So I'm going to multiply this side by -4, and that gets rid of that. And then I'm going to multiply this side by -4, and that gives me 4. So from there, some of you might realize, wait, I can just get a common base between these two of 2. So the left side already is a base of 2, and you don't need to touch it. And I can make 4 a base of 2 by making it 2 to the second power. And then cancel those out, set the exponents equal to each other, and you get -1. But some of you really like, there was no multiplication division to move, to undo the exponent to make a log. So that means I'd log the left side, log the right side. I need their base of 2. And then this becomes the argument. And this becomes the argument. And then those base 2's would cancel out, and you're left with -2x. And then you could go to your calculator and press that math button again. Hit that, put your 2 in, put your 4 in. You'll see you get 2. And then we're right back to where we were. I would divide by -2, and either way I'm going to get -1. All right, let's just move to 34. So 34, I have no idea what base would be in common between 6.92 and the other side. So here I'm going to have to go about this. And this is 6.92 to the x power equaling 214. So I never mentioned any addition, subtraction, or multiplication here. Instead, to undo that exponent, I'm just going to go ahead and make my log on one side of the equal sign and log on the other side. This will become the base. And then this will become the argument. And then my 6.92 can cancel out. And then whatever this is in my calculator, so I'll press that math button, put 6.92, scroll over and put in that 214. And then I'll go for 3 numbers behind the decimal, so 773 becomes 774. And the last problem. So this problem is looking very similar to 31, except I'd rather have 1 log here than 2 logs so I can do this eventual crossing out. So what I'm going to have to do is condense this log down. And just ignoring this log for now, x plus 6x becomes x times 6x. So that's actually 6x squared. Then I'll bring that log back. I never touched the other side, it just dropped down. And now that it's the same log on both sides, I can cross them off. And now to solve for x, I'll divide by 6. And now to undo the squared, I'd square root, and you get 3 and negative 3. Technically 3, whoops, you can't see that, is the only answer. If I put negative 3 back into my problem, I get an argument that's negative, and arguments can only be positive numbers. They can't be 0 or negative. So this is technically, this one is an extraneous solution, and 3 is the only solution, but we're not going to really worry about that too much, and if you notice it, great. If you don't, that's okay too. All right, a few more problems on solving. So if you notice, this problem is popping up again because it shows up like this on the test. And what I'm going to do is I'd like to cross off these logs, but I can't until I've dealt with this 1/2. So I'm going to move the 1/2 back as an exponent, but you might actually like this better as a square root. And then I'm just going to drop the right side down. And now, cross those off. And to solve for x, I would undo the square root. So to undo a square root, I'd square this side, which gives me x. And I'd square this side, which gives me 16. Okay? And the last one, I need to solve for x, which is an exponent. So here goes my list. And it's 1/2 times e to the x plus 8. So I did say these 2 steps. So I'm going to have to get rid of them because it's e to the x that's the base in the exponent. So first I'm going to subtract 8. Which gives me 11, and then to get rid of the fraction, I'm going to multiply by its reciprocal, so multiply this side by 2, and you get e to the x, which means I'll multiply this side by 2. And now to undo my exponent, I'll make my log, and I'll put my understood base, and then I need its argument, so this becomes the argument, and this becomes the argument. And just like before, they both have a common base on the left side. They can cancel out. And then log e is actually just ln. And then you can go to your calculator and type in ln 22. And we'll get 3.091. All right, last problem. And this is on here because it's also on the capstone. So I'm just showing you how this ties into our last chapter. So I did give you the formula, so you don't have to worry about which formula to use. But you take out a loan of $12,000 with an annual interest rate of 3.2% compounded continuously. You write an exponential equation that models the balance of your loan after X years. Then use your model to find how long it will take before you owe $18,500. So what's going to happen here is since I said compounded continuously, we use this formula. And remember, Y is now the new amount, so eventually I hope to have $18,500. P is the original amount, that's $12,000. E is just that letter, that 2.7 value. R is my decimal of 3.2%, so that's 0.032. And we're actually going to try to figure out what time is. And this is what we just did right here with different numbers. I'm going to work backwards in my order of operations to solve this problem. Now, last chapter, we would have put y1, y2 and looked for the exponent, but now we can actually solve it. So this is 12,000 times e to this exponent, so no addition, subtraction was mentioned, but I had multiplied that, so I'm going to move it over by dividing. So this side, I'm going to keep that whole decimal in there, but I am going to write some of it down. Whoops, it's an E now. And now to undo my exponent, I'm going to log both sides. So I'm going to log the left side, and I'm going to log the right side. I'm going to put its base in, and then this becomes the argument, and this becomes the argument. And then since these bases are the same, we can cancel this out, and we get left with this. And then log E, that's still ln, and then the 1.542. So let's talk about this. I don't want you to retype this decimal in, so you can press the ln, and to get this whole thing to show up, you can hit above the negative, it says ANS. If you hit second and then the negative button, it will take your most recent answer, put it in there, and then we get that on the left side. Again, I'm just going to write down some of the decimal because I'm not quite done. But now to get this t by itself, I'm going to have to divide this number. So I'm going to take this really long decimal and divide it by 0.032. So when we're done, this should take about 13.527 years. So 13 years. And I could take the 0.527 times 12 and realize that that's about 6 months-ish, a little more than 6 months, because there's 12 months in a year. All right, last one. You bought a new car for $11,480, and its value depreciates at this rate every year. So we're going to write the exponential model to see how much it will be worth in t years, and then we're going to use that model to find out how long it would take to be worth $5,000. So we're going to kind of just jump to this one. So remember, Y is the new price. It will eventually become $5,000. B is the beginning price, so that's the $11,480. I'll have 1. Since it's depreciating, I'll put the minus, and I'll put 0.08. That's my rate as a decimal, and then t years. So first thing I'm going to do is just get those parentheses down into one number. So I just subtracted those. And now to solve for t, working backwards. So over here we have this 11,000 number multiplying to 0.92 to the t power. So there won't be addition subtraction to move, but I will move this number because it's multiplying by dividing. So I'm going to take 5,000 and divide it by the 11,480. I'm going to get a long decimal and just write some of it down. And now, since it's just the base and the exponent, I'll undo the exponent by making my log. So log left side, log right side. There's my base. There's my base. And then my argument will be the 0.436 and this 0.92t. So what happens here are these common bases cancel out. And then I'll just go to my calculator and type this in. So first I'll have to press math and scroll up. And I can put the 0.92 in, but I want this whole decimal to go in there. So again, once I get to this, if I hit the second and the negative button, it will take this answer and just put it in there, and then hit enter, and it'll take almost 10 years. 9.968 years. So this is 9 years, and you could always take this decimal, 0.968, take it times 12, because there's 12 months in a year, and you'll see that's somewhere in that 11th month, so a little over 11 and a half months, so 11.6 months. So again, almost 12. And that's it. That is your review for Chapter 6. If you bring this back in completed, I will take your test score and I will bump you up a few extra credit percentages, not just points, but percentage points. I haven't decided on that final number yet, but hopefully it will, it gives you incentive. So bring this review back all the way completed, not partially completed.